All right, let's take a look at page 54. I believe we left off there yesterday. And we're taking a look at this graph of h of x and trying to identify the different characteristics and properties that we've been discussing over the last few days. I believe we wrote the equation, is that correct?
Yeah.
Did we do that? Did we do domain and range?
Yeah.
Okay, so we did that already. Did we tackle any of the other ones towards the bottom?
Yeah.
Which ones?
We did like, on the right side, we did like the first, the second, and third, and fourth.
We did these three?
Yeah.
Excuse the interruption. At this time, all 11th graders should report to the cafeteria to take the ASVAB. Also, please bring a pencil and a calculator with you if you have one. All 11th graders to the cafeteria. Also, all study halls normally in the cafeteria today will report to the auditorium. Thank you.
Good luck, guys. Anything for the office today? I think we're good. Thank you. Have a good day. All right, so we did this one, and this one? Yeah? Okay, so let me fill this one in real quick, too. Perfect. Okay, so these three that we did yesterday, we were looking at how the graph was related to the x-axis, whether we were on the x-axis, above the x-axis, or below. So what we're going to do is take a look at the next two underneath it. Notice how we have very similar notation, like we have h of x is less than 0, h of x is greater than 0, but now we have that bar in there. We did not have that bar in the previous two that we did yesterday. So if this question is basically the same as these two with that slight change, how do you think we have to take these previous two answers and change them a little bit to satisfy this equaling part now? What do you think, Alex? Yeah.
When it's like the x-intercept opposed to being a parenthesis, you make it a bracket.
We're going to make it a bracket. Okay, so this notation is asking us where are we below the x-axis, meaning less than 0, but the bar is now also representing that we equal the x-axis, or we are on the x-axis. So if we take a look at this, let's see, less than would have been this one. So we originally had -6 to negative, I did a fraction, but I think we did -3.5 yesterday as a decimal. So we're going to have the same values. What's different is whether we need to change a bracket or parenthesis. So the previous question, we had to skip over the x-intercepts because we strictly had to be below the x-axis. But now we can include the x-intercepts because we have that equal bar. So in our interval here, the x-intercepts were -3.5 and -2. So instead of these being brackets previously, they should be bars now. So it's basically the same intervals, it's the same values, but notice how the symbols change because the question changed. Does that make sense? Okay. If we look at the next one, again, very similar. Where are we above the x-axis or also on the x-axis? Because now we have that equal bar. So it's going to look very similar to the previous one we had. But now we should be able to include the x-intercepts. So instead of parentheses, we would need a bracket. And again, we said the x-intercepts were -3.5 and -2. Okay, so everything else stays the same. Bless you. It's just instead of having parentheses on the x-intercepts, now they're brackets. We can count them. We doing okay so far? Yeah? Okay. We're going to skip over the next two. I want you to try the bottom two. Where is h of x increasing or decreasing? Go ahead and check that out. let's see, if you were to trace the graph from left to right, you can kind of label where your pencil would be going up, where it would be going down. So it looks like we have 2 intervals for increasing, but also 2 intervals for decreasing. So we're going to have to use that U in there somewhere. The first interval, we have -6 to -3. And our second interval, we go from 1 to 3. Bless you. Question is parentheses, brackets, mixture. What do you think? Yeah.
All parentheses,
Why?
because it's either just starting it or is it evening out, so it's never increasing besides the points in between.
Exactly. So if you take a look at the points that we chose, -6 was a beginning point, like you're not even moving yet. That's where you're starting. And -3 is a change in direction, where you go from, in this case, up to down. So if you're changing direction, there's no way you're just increasing at that spot. Kind of the same thing on the next interval. Notice how 1 is a beginning spot and 3 is a change in direction. So increasing, decreasing, constant, all those questions would be parentheses. No brackets ever. So for decreasing, we can do -3 to 1. Notice how -3 was a change in direction and 1 is an ending point, so we can't include either of those. And the next one we'd have from 3 to 5. 3 is a change in direction and 5 is an ending point. So no brackets whatsoever. How'd you do? Good? All right. We're going to come back to the 3 that we skipped. So take a look at this kind of bigger box on the left-hand side. If P of X is that absolute value equation, we want to figure out which X values make this statement true. Can we think about what that notation is asking us to find? What does it mean when it says P of X equals H of X? Yes, ma'am. Intersection points. Where are the 2 graphs exactly the same, meaning where do they have the same point? Now, we have the graph of H of X because it's given to us at the top. Let's perhaps graph the P of X on the same paper, on the same grid. That way we can see where they would cross each other. So maybe we can use some of those transformations to help us graph this by hand. Do you notice any changes that we could use to our advantage? Yes, ma'am. Okay, so absolute value is a V. Normally starts like this. If you flip it upside down, now it's an upside down V. Okay, so it should be upside down. Definitely because of that negative. Yes?
Left 1 and up 3.
Left 1, up 3. So that's where your vertex is, that tip of the V. So if we go left 1, up 3, there's the vertex. We know the V should be going down. What slope do we need for the sides of the V? What do you think, Adam?
A negative slope.
A negative slope because we're going down, right? That's where the negative out front's coming from. Do I go down 1 over 1, down 2 over 1, down 3 over 1? How do I know the exact number, though? Yeah.
It says down 1 over 1.
How'd you know?
Because there's no stretch.
Right. Notice how there's no 2 or 3 or 5 or any multiplier out front. So the typical slope is just a 1 unless you're going to change it with that stretch. So we're going to go down 1 over 1, down 1 over 1, continue, 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 but we got to do both sides. So down 1 over 1, down 1 over 1, and keep going. Okay. So there's the graph of P of X. So Sam told us that we got to figure out where are these intersection points. That's where we would satisfy this notation, where they're exactly the same. Can we figure out where they would cross each other? Yes?
Wait, can they cross? Because aren't they open circles?
They are open circles. That's a great question. Can they cross? Can we include those values if they're open circles? No. So this is where you might have to be a little tricky. For those of you that actually drew the line all the way through, you may have gone over the open circles, which means you would have missed those. Okay, but we got to be careful. We can't really go over them because there's no point there. We have to skip over that. So it looks like that these would be intersection points, but since there's no point actually there to include or count, they would not be. Okay, a little tricky there. So we'll say there are no x values that work because there are no, I'll use true, okay, true intersection points. It looks like there would be some, but since they are open circles, we cannot include them. Does that make sense? Kind of a thinker. All right. The two that we skipped previously are also involving this graph or equation of p of x. So that's why I wanted to skip over them before. So let's take a look at this one. For which values of x is p of x greater than h of x? What should we be trying to identify graphically with that characteristic? Yeah?
Where is p of x higher on the graph than h of x?
There we go. Higher, above, anything like that. So p of x above h of x. Now this should be pretty simple for us to identify because we already graphed the function. So if we can identify where is the p of x graph above the h of x, maybe we'll start to drag our pencil to see. So on the left hand side, notice how the h of x graph starts at -6. So that's where we'd have to start our interval. And it definitely, p of x is bigger than h of x at that spot. As we drag our pencil across, we got to ask ourselves, do we come to a location where p of x is not above h of x? Yeah.
-3.
Why? That's good.
Because it's kind of like they're at the same point, so it's not above it.
They're at the same point, so one's not above the other one. We also
And there's also no point for p above.
there's actually no point there also, so kind of two kickers. So we're going to start at -6 and we'll end at -3. So at this -6 spot, we got to ask ourselves, do we have closed circles and does it answer the question at hand? Notice how h of x has a closed circle, p of x has a closed circle, or at least you could put one there, and p of x is definitely above h of x. So that's a yes all around. We can include that spot. We could not include -3 because that open circle, it has no choice but to be a parenthesis. All right, maybe there's some more intervals. So we stopped at -3. As we continue to drag, it looks like p of x is still above h of x. So we have another interval. Okay, we'll pick up at -3. And as we continue to drag, we got to ask ourselves, when do we come to a spot where p of x is no longer above h of x? What do you think, Alex?
1.
Why?
Well, because after that is below it.
After that, it's below it. Okay, so notice how at 1, right here, p of x is above and h of x is below, right? But after that, h of x is above and p of x is below. So 1 is kind of that changing spot. So we got to ask ourselves, is there a closed circle on h of x? Is there a closed circle on p of x? And does it answer the question at hand? Yes?
It's a bracket
Why?
because it is above and there's also a closed circle at -1.
Perfect. All right, so closed circle on p of x. We have a closed circle on, on h of x. And we would have a closed circle on p of x if we continue that absolute value all the way through. So both have closed circles. And notice how p of x is above h of x at that spot. So we could include that as a bracket. That one might have been a little tricky because you saw that open circle on the parabola, but we're not counting that point. We're counting this one. We doing okay? Yeah.
What about like the parabola that's above the absolute value that we just grabbed?
So this one right here?
Yeah.
So notice how this is saying h of x is above p of x. And this notation is wanting p of x to be above h of x. So we want the absolute value to be higher than the other graph. And here it's the opposite. This parabola is higher than the graph. Like if you were only looking at this section, like that, you see how the parabola is higher?
Yeah.
Okay, so this one would be h of x is bigger than p of x. That's not what this was asking us. Okay, but that's kind of what the next one's asking. Okay, so if you take a look at the next one, the notation, p of x is less than h of x. We want to figure out where p of x is below h of x. And I think Hunter already did that for us. So we went from -6 all the way to 1 for the previous question. And I think the rest of it's going to satisfy this one. So notice how from 1 to 5, because that's where h of x ends, that's where we have to stop our comparison, we have the h of x graph above the p of x graph. So we'll go from 1 to 5. We got to ask ourselves, bracket, parenthesis, mixture, what do we think? What do you think, Mike?
Parenthesis on 1 and then graph down 5.
Why? That's perfect.
Because you can't include 1 because like it's still above
Mm-hmm.
that part of the graph, and then 5 is below.
All right, so if we're just looking at the parabola, this had an open circle, so it had no choice but to be a parenthesis. And then when we get to 5, we have a closed circle on the parabola, closed circle on the absolute value. So those could be brackets. Does it answer the question? The parabola is above the absolute value, so that would be a yes. So we can include that one. Okay. I'm hoping we're getting a little bit better with brackets and parentheses, like whether we can identify open circle, closed circle, does it answer the question at hand? Do you think we are getting there a little bit? Okay. I mean, it's going to take some time. I completely understand that. And this isn't going to be the end of it, okay, because we are going to just have some more practice with this interval notation. But that's it for this section, okay? So not too bad, didn't take us too long. The rest of today you can use as homework or practice review in preparation for your quiz on Friday. Tomorrow we'll be having our first free response day. We're going to put you in groups, and you're going to be working on kind of those multi-part questions together. The homework, I had questions in other classes. The homework is not due on Friday, okay? It's due on test day, not quiz day. So we're not going to have a test for quite some time, maybe another 2 weeks or so. Okay, but that doesn't mean you don't do the homework. Okay, you got to keep up with it. You had a question, Sebastian?
No.
That was your question, okay, about the homework. Gotcha. All right, so we'll stop there for today. If you need help on any homework, let me know. Other than that, use your time wisely.